it's the end of the month and you just got paid, and you need to go to your bank because you need to withdraw some money and maybe pay some bills. When you get there, you realize that there is a lot of people that had to go to the bank the last day of the month. And you start stressing out because you have a lot of things that need to get done that day. This is a situation that we have in our everyday lives. I don't know, maybe when going to a supermarket, you have to wait in line to pay for the goods you're buying. What we might not be thinking a lot of is, how is this for companies? How is the other side of the coin? And along with that, operational managers have another thing in mind right now. It's inevitable to talk about the COVID-19 pandemic, as it has changed the overall dynamics of all kinds of business in one way or another. Given the difficult situation, the government institutions have released some specific laws for businesses in order to operate in the most secure way for clients. So, for example, now social distancing and occupancy monitoring of offices is now mandatory in a lot of cities in the country. It is required for companies to find effective ways to help the national aims to control the COVID-19 pandemic. This is a monitoring task that has to be attended as soon as possible. The thing is that queue systems and, in a more general way, office monitoring tasks are very hard to improve and very expensive to measure. So how are queue systems being measured? And as told by the company that reached us and told us, hey, we have a queue system problem. Our clients are giving us very bad reviews because they are waiting in line too much time. Well, you have to send 1 or 2 professionals each year to each one of your offices around the country. These professionals are well paid and travel expenses are included. When they get there, they have to take time for every single service given to a customer in that day. So as you would think, this is a very prone to error approach because humans are very likely to make mistakes. And on the other side, you are taking decisions on the measurements that you make that single day. So what happens if nobody show up? Or what happens if a lot of people decided to go to the office that day? You are taking decisions based on outliers. So we start thinking, and we came up with the idea of building a scalable solution that has to be both better than humans and cheaper, of course. And we came up with Aforo. Aforo is the real-time indoor occupancy monitoring and analytics application. What is a real-time indoor occupancy monitoring? For this, the first module of our application, we implemented a computer vision algorithm and deployed it on the edge using a Raspberry Pi and a camera widget. The action is captured by the camera, while the Python script running on the Raspberry Pi makes the magic to identify person objects with high accuracy. But it is not magic, is it? Aforo is built up by several systems that interact together in order to extract the most information of the environment where it is installed. The computer vision system was developed with Python and OpenCV, and it uses last generation algorithms for object detection and tracking. For this particular use, every person in the office is captured using an algorithm called YOLO-before, which is a neural net that has been pre-trained with a set of more than 300,000 images, and it's known worldwide as COCO. Once every object is identified, we filter the detections, leaving only the ones that matter for monitoring. The resulting detections are tracked using a deep sort algorithm that gives every detection an unique identifier to ease the time position calculations and database recording. We created an algorithm to keep the tracking updated and to calculate the state of the system in real time, giving us information about how the objects have interacted with the environment, which for this case, of course, is the office. The waiting and service times for each person identified are processed, having into account the time lapses between the in and outs to the predefined zones, the queue zone and the service zone. Those records are sent to the AWS cloud, where we hold an RDS instance running a Postgres database. Here at the office, the Raspberry Pi is also capable of displaying a user interface that we built using OpenCV, where the occupancy of the office is being measured. with a predefined value for the maximum occupancy for that office, Aforo will tell you what is the occupation percentage at any given time, which is really helpful for taking decisions on limiting the entrance to the system. We think that our product can help a lot of different businesses in order to fulfill the government requirements for COVID-19 pandemic. Aforo is not only a computer vision or monitoring solution for businesses. The analytics module is a set of tools designed to support management on the departments that handle the everyday operations of companies. The computer vision system is in charge of capturing the features, process them, and then transform the results in a structured way, which we can use now to make analysis and take decisions based on data. The analytics module is presented to the final user as a web application that is easy to use and helpful for understanding data. This web application was built on Python using the Flask micro framework, and it runs over an EC2 virtual machine on Amazon Web Services. This application queries the Postgres database in order to bring the information that the user is requesting. Let's talk now about the tools. The Q Models tool enables the user to make decisions based on the key indicators of queuing theory. It calculates per hour, per day, per month or per year the mean arrival rates and the mean service times. With that information, it could answer you questions like: what is the utilization rate of the system? What is the probability to have any given number of customers at a queue? What are the service rate for a specific server at a specific office? Among many other questions. The second analytics tool is a simulation tool. Using the SAMPy Python library, you can make simulations of the queue system based on historical data. Here, the customer arrivals are generated randomly following a Poisson distribution, and the service times are generated randomly following an exponential distribution. The third tool is the machine learning tool. Using different machine learning Python libraries, this tool enables the users to make predictions on office occupancies based on historical arrival rates. You can choose between three different kinds of algorithms: a linear regression, autocorrelated models like ARIMA, or a neural net with two Python layers that is optimized for time series predictions. We also created a parameter to include or exclude the COVID-19 pandemic data, because having to account this specific period of time will sure have an impact on your predictions. The fourth and final analytics tool is the dashboard tool. The dashboard tool is helpful for asking analytical questions on historical data and to identify trends and insights that are hard to see on raw data. You can play with this tool as it is built on the plotly-Python libraries, which are powerful and can give you the flexibility to shape your data as you will. We have selected some plots that we find relevant for queuing analytics and that will absolutely help the final user to have a fast glance on the system's behavior. Okay, we have seen a lot. I want to close this presentation making a summary of all the capabilities of the product. With Aforo, you can identify people in your offices with high accuracy using the Raspberry Pi and the camera widget. Once identified, the user interface running on the Raspberry Pi will tell you in real time what is the occupation percentage related to the maximum defined for that office. At the same time, the Python script running on the edge is calculating the queue and service time for each customer served, processing them, and inserting the results on the cloud database. When you have enough historical data of the queue system, you will start making decisions to improve the service using the different tools presented on the web application, like calculating queuing theory key indicators with the Q Models tool, or simulating the queue system with the simulation tool. Maybe you will be predicting office occupancies with the machine learning tool, or analyzing visually trends with the dashboard tool.
Gracias.
Gracias.